Good morning, guys, and welcome to your last lesson on remote learning for the year. So congratulations and awesome job for those of you who have still followed along and watched my videos as we went through. I am, really wishing that they helped. And, if you have any feedback to share with me on them, that would be greatly appreciated. You could just email me or send me a Remind 101 or put it on Google Classroom. You know how to find me. So for our last day of limits, we are going to be finding limits via graphs and talking about left and right limits. Now, at the top of these notes right here, it says, recall we have already established that if a limit is to exist, it must approach the same value from both sides. So in our last notes, we did a function, and I believe it was x minus 9 over x minus 3, and we decided it wasn't a polynomial, so we couldn't plug in. It wasn't able to be factored, so we couldn't cancel and get rid of the domain issue. So therefore we made a table. And when we made the table, one of the y values as we got closer to 3, x equals 3 went to negative infinity from the left, and from the right went to positive infinity, or vice versa. So what happens is when we say that we do not approach the same y value from the left and right as we approach the same x value, the limit does not exist. And we already learned that. But today we're going to be talking about it formally with left-hand limits and right-hand limits. So a left-hand limit, the only difference when looking at a left-hand limit, if you look, it says the limit of f of x as x approaches c, and then there's a little minus on top. So if you see the little minus on top, I'll try to highlight it in red. The little minus tells me you're approaching that x value from the left, okay? Whereas if you look at the right limit, there's a little plus. That means approach that x value from the right. So if I was making a limit for a left and say x was approaching 3 and there was a minus, I would approach 3 from the left. So 2.9, 2.99, 2.999. From the right, if I was approaching 3 from the right, it would be 3.1, 3.01, 3.001. So things we've already seen, but now we have formal notation. If you see the little minus, now it's not going to be in front. If you see approaches -2, there's a minus in front, it's just negative. If you see a minus or a plus on the top right, almost like a power, like a superscript, that's how you know it means left-hand limit, right-hand limit. Okay, so how are we going to do this via a graph? So if we look, find the following limits. The limits as x approaches -1 from the left. So if we look at this graph, now I have a few pages, so we're not going to do all of these on one page. What I want to do is I want to first look at this graph and say, okay, there's a lot going on. We have holes in the graph, which means those are open circles. We have jumps in the graph. We have cusp or sharp turning points. So we are going to find the following limits. Let's start with A. A says we are going to find the limit, and I'm going to rewrite it largely on the right, as x approaches -1, and then there's a little minus on the upper right of the -1. So that means we're going to approach -1 from the left of f of x. So if you notice here, they are not giving me what the function is. They're not saying f of x is 5x squared. We don't need to know what the function is because we're not plugging into the function. We're just using the function that they give us on the graph. When we are using a graph, what we're going to do is they're telling us what we're going to do. They're saying x is approaching -1 from the left. So what I like to do, remember, the x value is -1. So to the left of -1 is -2, -3, -4. The way I like to think of it is you are going to trace the function, so everything in red, all the way from the left until you get to x equals -1. So I'm not just going to trace, -1. I'm going to trace the function until I get to -1, but I'm going to trace it from the left side. So I'm going to trace it from the left side, and what you can see is my function is approaching what y value? That is what we are asking. As we approach -1 from the left, what y value am I going towards? And if you look, the y value I'm going towards is the y value of 2. That's the height I'm going to. So my answer would simply be 2. And once again, if you look at my worked out notes, I have little, I guess, notes on there, little statements that explain what I'm talking about in words again. Okay, so again, let me go through that. What am I going to do? It says find the limit as x approaches -1 from the left. So x equals -1. I'm going to trace the function. I'm tracing my function. Where is my function? What y value is it going towards as I approach -1 from the left? And it is approaching +2. Okay? Now I'm going to do the same thing, and this is just practice. You just get used to doing it, tracing the function from left to right. Let's look at B. B says find the limit as x approaches -1 now from the right. What is that going to equal? So I'm going to go to the right of -1. I'm going to trace my function. Now what value am I going to? If you look, my function is going straight towards 2 again. Okay? So from the left, so a little minus is the left, the little plus is the right. Now let's look at part C, and we're actually going to combine A and B. So if you look at part C, it says the limit as x approaches -1 of f of x. Now we're approaching -1, but if you notice there's no plus or minus. It's not from the right or left now. So how do we do something like this? Let's look at the previous slide. The previous slide said if a limit is to exist, it must approach the same value from both sides, from the left and the right. So both my left-hand limit and my right-hand limit have to be the same. The same value needs to come out. If they are not, the limit does not exist. We write DNE. If they are the same, then we just write, so if in this case, if L equals R, then that is just the answer. Whereas if L is not equal to R, and I'm using the way it's written above, we write DNE. Okay? So let's look at this one. So all we have to do, we don't even need to look at the graph for this one. We just look at A and B. And we're going to say 2 is equal to 2. So both of the answers are the same. Therefore, our limit is 2. How would we know if it was D and E? Say A was 3 and B was 2. Since they're not the same from the left and right, the limit does not exist. Okay? Definitely something, it takes more time to do. I'm going to finish going through this example, and then we're going to go through another one. But this is absolutely something you can find Khan Academy videos for, and you really just have to practice to get it right. Okay, so we did A, B, and C, so I'm just going to cross them out. Let's look at D. So D says, find the limit as x approaches -4 of f of x. Now, if you notice here, there's no left limit, there's no right limit. But in the last one, we needed the left limit and the right limit to get the answer. So guess what we're going to do? We're going to find the limit as x approaches -4 from the left and from the right. And if they're both the same, then we have our answer for part D. So I'm going to start with the left-hand side. The limit as x approaches -4, remember we depict left with a little minus of f of x, so I'm going to go to my graph. -4 from the left, so x equals -4, here it is. I'm going to trace my function that's going towards x equals -4. When I get to x equals -4, what y value am I going to? And if you notice, my y value is 3. So my answer for this one is going to be 3. Your answer is always a y value. Next, I'm going to find my right limit. Whenever they just ask you for a general limit now, you need to find the left and the right. So my right limit, let's write it out for notation. X approaches -4 from the right of f of x. So that will be equal to, let's see, so -4, I'm going to change colors so you guys can see it. I'm going to use purple. So -4, we already know where it is. I'm going to trace my function, my piece that's to the right of -4. And I'm going to trace it, and when I get to -4, what y value am I approaching? I'm going to approach my y value of 4. The graph doesn't label it, but it's 4. is my height. So now I'm going to go back to my original answer. They want the limit of f of x as x approaches -4. You're going to look at the left limit, look at the right limit, and you're going to ask yourself, are they equal? And I think it's very clear that 3 does not equal 4. So the answer, the overall answer to part D is D and E. And you're going to say, this is a lot of work. It is, but you're not doing that many, and once you get quick with it, you know, if I look at -4, I can clearly see that they're not approaching the same value. So you definitely get quicker with this as time goes on. But the overall answer is D and E. Okay? And let us do one more here. So our last part that we need to handle is the limit of f of x as x goes to 4. So we didn't see this yet. So limit as x goes to 4 of f of x is equal to what? Like I said, they don't ask you for it. You need to find the left limit, you need to find the right limit, and you're going to ask yourself, are they equal? So the left limit, I'm going to write it out. I really want you guys to get used to seeing this notation. You'll see it next year. So the limit of f of x as x approaches 4 from the left side. So I'm going to find x equals 4. I'm going to mark it. So I'm approaching that from the left side. So I'm going to trace the piece of the graph that's to the left. And what y value am I going towards? -3. From the right, the limit as x approaches 4 from the right of f of x. So I'm going to trace it from the right. What y value am I going to when I hit that 4? I'm going to -2. So you're going to ask yourself, are the left and right limits equal? Are they equal? And I think it's very clear, -2 does not equal -3, so therefore the answer does not exist again. And this will happen on graphs like this a lot, specifically when they ask you about certain ones. Okay, when they ask you, sometimes they'll ask you about the ones that, you know, have jumps in them. Okay, and let's go to the next one, our last example where I threw in a little bit of something different. So I think this is same one. Okay, example 2. So in example 2, you can see this one definitely has a lot of different dips and things. You are going to find the limits via the graph, and you're also finding f of 5. So what I want to do is I want to get f of 5 out of the way. What does it mean to find f of 5? It means what is happening. You know, if I asked you to find f of 5 for x squared, you would just plug 5 into the function. All we want to know is what is happening at 5. Not from the left, not from the right. It's not a function. You would just want to know what's happening at x equals 5. What is the answer? Now, what's harder about this is what you want, whenever they're asking you for f of 5 or f of 2, you go to that x value and look for the solid dot. That is the y value you want. So the y value we want, if we look at 5, we have two different y values. We want the solid dot. So f of 5 is just a height of 0. If I asked you, for example, for f of 1, look at 1, the y value is 3. You're just finding a y value at that point. If I asked you for f of -5, you're going to look at -5. You're looking for the y value for the solid dot. The solid dot is at a height of 2. Okay? So that's how you want to go about doing those. And I'm just going to erase the two bottom ones just for room's sake. So we found f of 5. It's equal to 0 because that's where our solid dot is. So now we're going to move back into limits. So we're going to start and we are going to find, for part A, the limit as x approaches 1 from the left of f of x. And remember, the negative says we're finding a left-hand limit. So I'm going to find x equals 1. And I'm going to trace it from the left. And you're going to see what y value is it going to? A y value of 3. So my answer for that one is just 3. Okay? Let's look at part B. And I'm just going to put it up here. The limit as x approaches, guess what? 1 from the right of f of x. So we're going to go, I'm going to clear the image out so we can see it. You might want to use colored pencils here, or something erasable maybe to help you. We're going to trace it from the right of 1. And what y value are going to? 3. Again, that's a little hard to see. It's a little better. Okay, so we're going to 3. Now C, it should be no surprise. Part C is asking us for the limit as x approaches 1. Not from the left and right, we already found that. So just 1. So what do we do when we just find a general limit? Well, you just look at the left limit and the right limit, and we're going to say, are they equal? Well, according to my calculations, 3 does equal 3, so the limit is just 3. So if the left and right limits are the same, the answer is just the y value that you got. So in this case, it'd be 3. If they're different, D and E. Okay? And then, of course, just like the last one, we did A, B, C, we found f of 5 and a few other values. We are going to start with part D, which is finding the limit as x approaches -5 of f of x. So they're not asking you for the left and right limits, but you have to find them. So I'm going to start with the left-hand limit. So the limit as x approaches -5 from the left of f of x. So I'm going to find -5. The piece that's of the left of that is this function right here. I'm going to trace it, and I'm going to be approaching a y value of 2. From the right, the limit as x approaches -5 from the right, my little plus sign of f of x. Change up my colors. I'm going to trace the part that's from the right of -5, and it's going to go up to a y value of 3. When you're doing limits from the left and right, it doesn't matter if the circle is for the y value is open or closed. You're just asking what y value you're going towards. So in this case, for the right-hand limit, I'm going towards 3, the height of 3. For the left limit, I'm going towards a height of 2. And then for our overall limit, for our actual question, we want to know, are the left and right, are they equal? They are not equal, so therefore the overall answer to D is D and E. Okay, and like I said, you guys will get so much quicker at this. And then last but not least, we're going to use this same graph, and we are going to find the limit as x approaches 5. So what you guys can see, if we look at 5, I'm just going to clear out all this bottom. So now we are approaching +5. So again, I'm going to find the left and right limit. So the limit, overall, I'm looking for the limit as x approaches 5 of f of x. So I want to know what is that. So I'm going to start with the left-hand limit. The limit as x approaches 5 from the left of f of x. So 5 from the left, I'm going to trace it. I end up getting to, remember, you're always looking for a y value. A y value of 0. My height is 0. So at that point, when I get to x equals 5, my y value is 0. I'm also going to find the right limit. So my limit as x approaches 5 from the right of f of x. So from the right, I'm going to trace it. What y value am I at? I'm going to go to a y value of 1. Again, ask yourself, is my left limit and my right limit, are they equal? And I would say they are not equal. 0 does not equal 1, so therefore the limit does not exist. And I'm going to put that again in a different color, not that color, this one, so you can see it does not exist. So that would be my overall answer to E. Okay? It's a good habit to show this work. You guys, again, you have, I believe, a lesson check, and then you'll have your last practice sheet, and then of course you'll have your last quest on the year. After you do your practice sheet, you'll have your last quest of the review. You'll have a review, sorry, and then you'll have your last quest of the year. I believe it's on the 15th or the 16th. You can check Google Classroom. I'll post updates about that, and it will be on all these different types of limits. Okay? Good job, and keep up the good work.